So thank you for joining in. I know it's the last day of KubeCon, but lots of folks I think are also streaming in from the keynotes. So welcome everyone. Today we are covering in this session lots of cool things about Cortex. How many of you use Cortex today? Awesome. Very cool. And those of you who are not, you should definitely consider it. So today we are going to talk about the project, provide some updates on the new features that have rolled out already this past year, and also give you an update on the roadmap that's coming forward for this coming year. I'm Alolita Sharma from Apple. We also have our awesome maintainers on the project here, some of them joining in today. Charlie Lee from Apple, Daniel Blando from AWS, Daniel Sabsay from Adobe, and last but not least, Friedrich Gonzalez from Adobe. So again, all the maintainers have been working on this project for a while, and really excited to have them all here today. So in case you don't recognize them on stage, here they are again. and they will be covering different parts of the agenda. We'll be starting off with an introduction to what Cortex is, but also diving into the architecture a bit, and kind of talking about the different moving parts. Charlie will be also then diving into a super cool demo to show you how to get started with Cortex if you don't know so already, and kind of walking you through a couple of scenarios. Then the maintainer team will be actually providing an update on the different features that have been rolled out for performance or scalability, reliability, and others. And then we'll talk about what are some of the cool features that are coming in terms of interoperability, compatibility with new formats and upgrades on the protocols. And last but not least, we'll talk about the roadmap to graduation. Again, the project is looking to graduate. Again, it's super exciting. We're at that time, where we are just kind of getting ready. So Friedrich will be diving into that. And then if we have, a little bit of time, please hold your questions till then. And if we do run out of time, please, do find us, hang out. We are happy to hang out and talk more about things. So as many of you know, Cortex is a very highly scalable, specifically horizontally scalable, highly available multi-tenant long-term storage for Prometheus. Again, it is a very popular multi-tenant solution for most large and small organizations that are looking to isolate data. And Charlie will be diving a bit more into the features. So Charlie, over to you. Sorry.
Thanks, Alolita. So I'm going to be talking a little bit about Cortex, what it's about. Like Alolita said, it's a horizontally scalable version of Prometheus. It tries to have the lowest response times possible for queries and writes to it. There are a lot of strong stability guarantees, which I'll talk a little bit more about, and it's community managed. Like you see here, it's backed by multiple companies, and there are lots of diverse contributors all around the world that are helping to build it. This is the architecture diagram that is on our documentation. If you've read it, it's you've probably seen it before. But at a high level, there's the write path, which is the orange line here, where something like OpenTelemetry or Prometheus sends metrics to Cortex, and then it lands into the distributor, which is a service inside of Cortex which handles rate limiting and fanning out of those requests to an ingester, which is the second part of that write path. And the ingester is responsible for storing the metrics so that you can query them in memory. And then when the ingester has enough of your metrics for, I think, 2 or so hours, it will compact them just like the Prometheus service does. And then the ingester will send those compacted blocks to some object storage of your choice. So that way you could have long-term storage. So in this case, it could be S3 or Google Cloud Storage. And we'll talk a bit more about what are these supported object storages. And then on the read path, there's dashboards like Grafana that will query Cortex so that you can query all of the metrics that you sent it. And when you query Cortex, you pass in a header, which signifies which tenant you want to query the metrics for. And there's a lot of caching features as well, so that it doesn't have to go through the whole query path to get the metrics that you want for your tenant. So how's it different from Blank that does something similar? So with Cortex, all of the components that you saw earlier are horizontally scalable. So if you wanted to scale up some component there, you could. And there are no unexplained metric gaps, so anytime you restart something, there's always some sort of availability or high availability setup where something else will take on that load. Query speed is also a very important feature for Cortex, so we try to optimize aggressively on that. And there are also strong stability guarantees, so whenever there is a new feature, we always mark it as experimental so that users of Cortex aren't surprised. And the CNCF project is also backed by many developers from multiple companies, so you can tell that the community is quite vibrant and healthy. And here's just a quick table of what Cortex is about. It has object storage, scalability, performance, data resilience, and data flexibility, and it's community-driven. So this is our getting started. We have a page on our documentation that shows you how to get quickly started with either Docker or Kind, whichever you want. The Docker one has a single binary mode, so you can just have Cortex running as a single binary in Docker and then play around with that. There's also the microservices mode, where you can have Cortex broken up into the microservices that it is made up of, and then see how those components interact with each other. But I wanted to show you a little demo of Cortex in action. So on the right here, I have just an empty Kubernetes cluster. It's just running on my machine here. And these 3 pods are just part of the Kubernetes cluster. But what if let me just double check that all these values are correct here. Sorry, I was testing this earlier, so I need to reset these back. So I'm going to apply this Helm file, which has a couple of charts that it's going to install. Cortex itself in microservices mode. So Cortex, like I said earlier, is made up of multiple components here. So there's the ingester, which stores the metrics. There's the distributor, which is the front door for all metrics that get ingested in. I just have 1 replica here and 3 replicas of the ingester. Nginx is basically our HTTP router here. There's the querier, which executes the queries, and all of these components are scalable here, so it'll take a second to load these all up. I also have some Prometheus pods here that will be scraping metrics in the cluster and then sending them into Cortex with their own tenants. So imagine you have a dev tenant and a staging tenant, and you want to have isolation between the 2 tenants. You can have that, and it's possible here. I'm going to show you how. So yeah, I just have these 2 Prometheus instances that are sending metrics to Cortex. So let me port forward into Grafana so that I can show you. There's also Grafana running in this cluster. So let me create some data sources and some dashboards in that Grafana instance so that I can visualize some of the metrics that are coming in. So in this dashboard, I'm showing the ingestion rates for samples between the 2 tenants. So I have a dev and a staging tenant. Both of them should be sending the same metrics. And I also have some rate limits over here. So each tenant currently has 25,000 samples per second as their limits. And on the bottom, I have what each ingestion or each ingester pod is currently ingesting per second for samples. The first thing I wanted to show was how I can dynamically rate limit a tenant without restarting anything on Cortex. So what I'm going to do is go into my Helm file where I have some overrides for these tenants here. So let me just change this 25,000 to 2,000, apply that again. And you'll see that that is the diff here, is this change for the dev tenant from 25,000 to 2,000. If you notice here, none of these pods got restarted because these values that I'm setting are runtime configuration values, so they don't require a restart, and each of these services are programmed to reload these types of values every so often. I think it's 10 seconds by default, but I've changed it to 1 second so that we can try to see it faster. So if you notice here, the ingestion rate for the dev tenant is actually going down to 2,000 like we expect. And then over here, you can see the limit as well got set to 2,000. And then for further proof, you can see the ingester pods actually are seeing less metrics coming in, which is working. So the demo gods are praising, or are happy today, I guess. So there's one more thing I wanted to show, and that is how do you automatically scale up ingesters so if you want to store more metrics. And to do that, I'm going to set the ingester pod replica count to 4, and you can have this be done automatically, based on scale or some other metric. So let me go ahead and apply that. And we should see one more ingester pod coming up pretty soon here. Cool. And I'll load the logs here so you can see it coming up, but I have the logs here for this ingester pod coming up, and then I also have this panel here on the bottom that is showing what is the ingestion rate for each of those pods. And if everything is working correctly, we should see those 3 ingester pods giving those metrics that it was ingesting before into the 4th ingester pod that's coming up. So we should see the 4th ingester pod increasing in samples ingestion, and then the other 3 decreasing as it's being load balanced across the 4. So that seems to be working as expected here. So you can see the new one coming up, and then the other 3 kind of releasing those samples that are coming in. So that is what I wanted to show for Cortex and how you can quickly kind of change things and see things working in a multi-tenant way. And I'll hand it back over to Daniel to talk about what's coming, or the team updates for the community in Cortex.
Thank you, Charlie. Since the last KubeCon in North America 6 months ago, we've had 1 release, 9 new contributors, 3 new triagers, 381 commits. We've recently added this new triager team, which is a group of contributors that contribute just like external contributors do, but with more persistence, and they have a little bit more permissions to manage PRs and issues to help alleviate the admin overhead on the existing maintainer team. The current team of triagers is made up of Anand Rajagopal, Sungjin Lee, and myself. In this last release, version 119, we have a bunch of new features. The first is that OpenStack Swift as an object storage backend is no longer experimental, which means that the 4 officially supported backends are Amazon S3, Google Cloud Storage, Microsoft Azure Storage, and OpenStack Swift. There are 2 new features for the Cortex ruler. This component is the component of Cortex that evaluates Prometheus format recording rules and alerting rules. We've had this component that runs as a microservice inside Cortex for quite some time, but prior to release 119, it has not been properly highly available. Thanks to the work of, and apologies for mispronunciations, Alan Pertagio, Yiji Chin, Wilbert Wool, Soon Ping, Anand Rajagopal, and Emmanuel Lodovice, we now have experimental support for high availability. Unlike the high availability that we use in distributors and ingesters, instead of using pure replication, we use a primary versus non-primary approach. In this approach, each rule group is assigned to a set of ruler instances, but is only evaluated by 1 instance in that group of rulers. At each rule sync, which happens by default every 1 minute, The non-primary will check the health of the primary, and if the primary is unhealthy, the non-primary will take ownership of those rules, begin evaluating them. So you see two scenarios here. The third scenario not shown is that if both ruler 1 and ruler 2 are down, the next non-primary in the chain, there is an ordering imposed. Ruler 3, in this case, will take over ownership, and when the other rulers come back alive, they will relinquish ownership. This approach helps us minimize gaps when rulers restart and fail, but also avoids redundant rule evaluation. So at any one time, a given rule is only evaluated by one ruler. This high availability is also availability zone aware. The second feature that we've added to the ruler is the option to use the existing query path. This means that rules evaluated by the ruler now take extra network hops, but allows you to take advantage of the caching and query splitting performance enhancements that exist in the query front end. This feature was contributed by Sungjin Lee and Bin Yi. And now I'll hand it to also Daniel to talk about more features in version 119 and upcoming.
Thanks, Daniel. The next feature that we released on 119, it's the partition compactor. We have been talking about it for a while. We did do a talk on last KubeCon. Like it went very deep dive on it. So if you are interested, please take a look at the talk. The partition compactor mostly helps us with the limitations from TSTB index, which is 64 gigabytes, and it helps also if your use case has more blocks or bigger blocks to speed up compaction. That was problems for us that we had it. Another feature that we are working on recently, not recently, but we already have for a while, is OTLP compatibility. We already had it for Cortex, but we are still working in improving and adding more functionalities. One of them is the max request size limit that was added to prevent, for example, out-of-memory issues. We are also trying to be as consistent as possible with Prometheus OTLP compatibility. So we also added the target info metrics by default. And we added a new proposal that was passed on Prometheus and was already implemented in Prometheus, which is called a configuration called promote resource attributes. That configuration allows you to add custom labels for your metrics. That helps a lot in OTLP cases because sometimes you want to add a different label for querying or for aggregating the data. For example, you can use the labels from target info to do that. The other part that we are currently looking a lot on it is ingestion optimizations, focus on CPU and memory. One thing that we added as experimental for 1.19 is something that we call push workers. Credits for gRPC, they actually were looking at that, and we are getting the idea, implementing in Cortex. Basically, the idea for push workers, if you look at the pprof there, we have a place called new stacks. And what's happening there is like when we create new Go routines, we have this new stack, and that burdens the CPU. So what we added a workers pool for managing Go routines. So instead of creating new Go routines every time, if we have in the working pool, we reuse them, avoiding this new stack to be creating every time. In some use cases, not all, but we are seeing improvements up to 20% of CPU on ingesters, which is pretty good. So if you guys have problems with CPU sometimes, take a look, try to enable this and see how it goes. Let us know. Another improvement, enhancement that we did it for ingestion optimizations, focus on CPU again, is expanding posting cache. That's something that was already added in Store Gateway. I don't know if you guys are familiar, but the idea is instead of caching the result of our query, we cache the postings of the query. So instead of receiving all the response from the query, we basically get the query and see which postings are going to be related to that query. The idea here is because some of the queries are very complex and very burdening on CPU when they are loading a lot of postings, or when there's rejects that want to match for a lot of postings. For store gated, that was easier just because we don't have the head block. For ingester, that was a little bit more complex because we had to add some invalid cache for that. If we just added that to the ingester, we could have wrong data. So what we did is every time that we receive a new sample that matches a posting, we invalidate the cache for that posting. So it's not as good as store gateway, but it also helps a lot. There's a lot of graphs here, but if you look at the first one on the left for you guys, you can see the difference on CPU usage. We also see an improvement around 20% when we enable this. So it's another thing that you can try and see how it goes. It really depends on the type of queries that you have. If you have a lot of regex queries, that can help a lot. Another part of the code that we are looking a lot is scaling Cortex and a lot of focus on ingestion itself. As you look at for the demo from Charlie, scaling up ingesters is pretty easy. Like we just enable, it goes to the ring, and that's it, it works. Scaling down is a little bit more complex, just because the ingester for us is the hard data layer. So if we just scale down ingesters, we basically have not opportunities. We can have issues about losing data temporarily or permanently, depends on how you configure your Cortex. We do have flags on configuration to avoid that. The problem is that those flags can also cause query performance issues, for example, high latency. So what we did was we added a new state for ingesters. For the ring itself, it's called read-only, but basically ingesters use it. The idea is, if you have a new read-only ingester, it's still active on the ring, it's still visible for everybody, but it's not receiving any information. So if you look at the first graph there, I have some red lines. The first one is setting the ingester to read-only. And you can look in the second matrix below it, which basically shows the push requests for those ingesters going to 0. So the idea is the data is not going to ingesters anymore, but the data is still being queried from ingesters. So if you look at the metric on the side, you can still see that the query request maintains the same, but the push request drops. So with that, and additionally, we also add a new API on ingesters, which is basically to get statistics from ingesters. The API basically tells you if there is any blocks loaded on ingesters. So if with these read-only and the API, we can safely assume when we stop receiving data, we can safely assume when we don't have any more blocks on ingesters, and then we can scale down ingesters, because on that time, we don't have any more information to query on those ingesters. Another thing that we improved on the release 1.19, for those that use HA on Cortex, which is a feature for Cortex, previously we only accepted one HA pair by request. So if you have a request with different samples, but different HA samples, HA pairs, we basically would get the first one and ignore the rest. So it doesn't work. And how you prevent that is basically creating different requests, which is not ideal. So right now we have an experimental flag that you can enable, which allows us to have mixed HA pairs. So the idea is we look in the request for each HA pair for each sample, and then you don't need to create a bunch of requests. That's something that was annoying for users sometimes. So now, what we are currently working on and what we are trying to release the next versions. We are still working on the OTLP compatibility. We already have OTLP, but we got merged the OTLP metadata conversion. So now we convert OTLP metadata also, and that was already merged, so it's probably going to come in the next version of Cortex. Continue with the improvements. We are also working on another improvement for ingestion CPU. The idea in this one is instead of creating connections every time, we open a string connection between distributed ingesters, and we leave it open. We have a keep alive for that string connection, and then we don't have the burden to create connections to manage connections every time. From our tests again, we are seeing a 10% CPU improvement. This one is still open. We are still having discussion about it. So if you are interested, go take a look at the PR. Another big topic for us is native histograms. We already support native histograms in ingesters in Cortex. But we were missing the custom buckets native histogram, and that's something that we are working right now, and it's going to be coming in the next features, in the next versions. And lately, the big topic, which is Prometheus 3.0, so how we are doing on that, we are actually talking a lot internally about it. We are trying to support more and more Prometheus 3.0. So we have a PR open for the remote write v2 part of it, Prometheus 3.0. It brings the headers, the new headers that Prometheus, the remote write v2 has. And it also brings the string internally, which also is going to help with the CPU performance for ingestures. So if it's something that you are interested, we are having discussions discussing how to implement that in Cortex. That's it for me. I'm going to pass for Friedrich for the roadmap.
Thank you, Daniel, for the amazing updates. It's been an honor for me to work for Cortex for a number of years. I started as a user, then became contributor, and then became maintainer, and well, now I'm here talking to you about the project. And what I want to talk to you about is we have a number of users, a number of companies, pretty large using, and we need to organize to get the project in a roadmap that is cohesive, right? And this is what we've decided, is that we have this feature or GitHub that we're going to be using to handle the projects looking forward. And we have organized all the features in this buckets. I'm going to talk to you about one specific one that has been long coming, and it's the one about the graduation. The graduation of Cortex means for us a milestone. Is not the end line. We have even more things to do, but we think the graduation is what we need to be doing next. There's many adopters of Cortex, public and private, so we think we will fulfill all the requirements. The things that we're going to be working on and that we are missing over the course of this year is this third-party security review, and also document the roadmap change process so that we have a more inclusive governance. Also, in the release management, we need to finalize some details. That's all I have. We're moving into questions. Thank you for being here. Thank you for listening. Thank you for contributing to Cortex. Thank you for your next questions.
I think we have a few minutes.
Yeah, I think, let me check.
A couple of minutes.
Yes, we have like, 7, 8 minutes? 2 minutes? Okay,
Yeah.
okay, 2 minutes. Okay.
Anybody has questions?
Anybody has questions? Does the mic? If not, okay.
All right.
All right.
Hey, is there any discussion in Cortex to, I say the storage layers that Cortex storage is like S3 or GCS and so on. Is there any discussion to consider as our ingestion to analytic storage?
No, at this point, no, we don't have an issue for that. No, nobody has. That's the first time I hear that. But you're welcome to create an issue. What's typically happened is you don't know that is other people in the community want anyone you want. So the first thing I would say, I would create the issue. Don't just ask the questions if you're interested. Yeah. Go ahead. Yeah.
Any other questions? Daniel, do you want to talk about some of the issues that exist?
The last thing that I'll add is that if you are eager to contribute, you are all invited to check out our GitHub project, github.com, Cortex project/Cortex. There are a lot of issues, and you can check out the good first issue label. You can filter by those, check those out. We're happy to have your contributions. Thanks again for being here.
Thank you.